Hi, in this video I want to talk about the requirement of primer molecules. Now, synthesis of DNA is done by the DNA polymerase, right? However, given a template, right? If you give a single-stranded DNA template and you put DNA polymerase, it doesn't really do anything, because a DNA polymerase can extend from somewhere, but it cannot initiate. So that's why you need a primer molecule. So this primer molecule is synthesized by an enzyme called the primase. Primase is a type of RNA polymerase. So it is also a polymerase. But in this case, it's an RNA polymerase, so it synthesizes RNA. So basically, the primer molecule is actually an RNA molecule. So that's why you need to synthesize a starting fragment, if you must say that. So that starting fragment is actually an RNA molecule. Once you have that starting fragment, the primase then stops and then allows the DNA polymerase to take over and extend. All right, so that's why for replication, you need the primase. Primase is an RNA polymerase to start off, making the primer molecule, and then this primer molecule will contain the 3' OH, which is necessary for DNA polymerase to extend and carry on with the synthesis. Now, for the leading strand, you require a synthesis of the primer one time only at the beginning, and then because there's no problem, because synthesis follows the direction of the replication fork. So as you get more DNA, so synthesis of DNA just continues on and on and on until it reaches the end. But for the lagging strand, the synthesis is on the opposite side. It goes away from the fork. So that's why, if I rewind this a little bit, so as the fork moves on, right, it requires the synthesis of a new primer molecule. All right, this is a primer molecule, and then your DNA polymerase can join in and continue this strand to cover that up. All right, now you go and watch the videos. You can see this, I think, in the first two videos, not the one in DNA Learning Center. Right, it gives you the explanation quite clearly, but however, it gives the impression, if you look at the video and if you look at this drawing, it gives the impression that these two synthesis goes in separate direction. But in actual fact, right, leading and lagging, the enzyme, the polymerase, is done by two different enzyme or polymerase two different parts of the enzyme polymerase, right? So it's actually together. And if you look at the video in the DNA Learning Center, you'll find that these two actually moves together. So how is that possible? That is possible because the lagging strand is looped, right? It's looped in such a way that it still moves together, even though in essence it's actually what is happening is that one is still following the fork, the other one is actually moving against the fork. You have a look at the video and try to understand that. All right? Okay, see you later.